We're picking up with composition of functions here. So here we're just going to plug one function into another function, okay? So big picture, these are the notations you may see. A bunch of parentheses here. Both of these are read as f of g of x, okay? Your inside function here is g of x. You're just going to plug in g of x wherever you see an x in the f function, right? You may also see it represented here with this open circle. Notice it's different from your multiplication closed circle. Okay, they're both read f of g of x. We can change up the order. We could say g of f of h of t of x. All right, and then so t of x would be plugged in to the h of x function, and that would be plugged in to the f function, which would then be plugged into the g function. Okay, so all sorts of fun things we can do with compositions. This is the main way that you will see them. All right. Because going forward in calculus, okay, calculus is all about continuous functions, okay? So continuous, it just means that we're going to be working with equations in terms of x. All right, so here f of x equals 4x to the negative first. Notice that this would be the same as 4 over x, meaning that we need to be careful with our x's. We would not be able to plug in 0, okay? So x here could not be equal to 0 in that original function. G of x equals 5x minus 2. So let's dive in. We're going to plug in our inner function anywhere we see an x in the outer function, okay? So f is our 4, and then x is being raised to the negative first power. I'm going to leave a blank there, and we're going to plug in g of x into those parentheses, okay? Now let's ask ourselves real quick, what are we able to plug in for x right now? Right, that's going to be our long-term thing, okay? Notice that this negative first exponent is only going to the 5x minus 2, meaning we want to send that quantity to the denominator. And our 4 will stay in the numerator, okay? So this is our function. This is our f of g of x function. What can we not plug in for x? Looking at our denominator, we want to make sure that denominator is not equal to 0. Okay, so a couple steps solving through. If we treat this like a linear equation, add 2 to both sides, we want to get that x cannot be equal to 2/5. All right, x cannot be equal to 2/5. So we need to represent that in our domain. Okay, in interval notation, we want to skip over 2/5. So we want to go from negative infinity up to 2/5. Close your parenthesis, union, pick up at 2/5, comma, positive infinity. Okay. G of f of x, we're going to go the opposite way. All right, so our outside function is g. We want 5, and then we want some space, minus 2. Make sure my laptop's not going to die here. And then we want to plug in 4x to the negative first in those parentheses. All right, we'll end up with 20 over x minus 2, just the way this simplifies. That's our function. We want to make sure that 0 is not included in the domain. So our domain is going to be negative infinity up to 0, union 0, comma, infinity. Okay. Then here f of x, so if we plug f into itself, we have 4, and then something being raised to the first power, we're just going to plug in that f function again, and then we end up with, let's see, 4 over 4x to the negative first, which then becomes 4x over 4, which then just becomes x. Okay. What's our domain here? Our domain still has to be what that f of x is restricted by. Okay, so our domain still has to be that negative infinity to 0, union 0 to infinity. Okay, it's because the inside function, this has a restriction. Right, this inside function has a restriction, and that inside restriction will carry through to the end. Even though right now it looks like we could plug in any value for x, that inside restriction will follow through, okay? Pause the video, give this a try. It's going to be much more straightforward for you. All right, g of f of x. F of x is our inside function, so we want to plug that into our g function. So we're going to leave some parentheses squared. And then what are we plugging in? We're plugging in 2x minus 7. Be careful here. Remember, we cannot distribute that exponent over to the 2x and the negative 7. We have to write it out like this. Okay, 2x minus 7 times itself. Use FOIL. Multiply first, outer, inner, last. You'll end up with 4x squared minus 28x plus 14 plus 4. And that will, once we combine these like terms, give us 4x squared minus 28x plus 18. Okay. Our domain. So our what's nice about this problem is that all functions are good with all real numbers. Okay, negative infinity to positive infinity. We can plug anything in for x here. We can plug anything in for x in our inside function, right? This f of x, we can plug anything in for x there, so our domain carries through to be negative infinity to positive infinity. This one, start inside, okay? F of 3. What is f of 3? So let's plug in 3 for x here. 2 times 3 minus 7 gives us negative 1. And then let's plug in negative 1 to our g function. Okay, what is g of f of 3 is really asking what is g of negative 1? Negative 1 squared plus 4 gives us 5. So 5 is our answer. Okay, the domain here, because we don't have any x's, we don't really have to worry about domain. I would never give you a question like this, but just in general, the domain we're plugging in here is x equals 3. All right, so that would be your domain. In interval notation, just to be consistent, you would put a bracket around 3. F of g of x, so now we're going to go the opposite way. All right, f is our outside function, so we're going to put 2, leave some parentheses, and then minus 7. Plug in your g of x inside there, x squared plus 4, distribute, combine like terms, and we will be good to go. All right, you end up with 2x squared plus 1. Do we have any domain restrictions in our originals? No. Okay, g of x has no domain restriction, nor does this function we ended up with, so our domain would be negative infinity to positive infinity. Okay. Discrete. So these will take a second for you to wrap your minds around. Discrete functions are not continuous, all right? It's the opposite of continuous functions. So when we say discrete functions and I give you a set like this, f of x equals this set of ordered pairs, and then g equals this set of ordered pairs, it's just going to be like points that are graphed, right? It's still going to pass the vertical line test because we have a function. They're not going to be connected. That's what discrete functions mean, okay? So start inside. G of 8. What is g of 8? When you plug in 8 to the g function, you get 15, right? Now let's see, when we plug in 15 to our f function, what do we get for y? We get 11. All right, so 11 is what you want for your answer. Start inside, g of 9. When you plug in 9 for x in this bottom g function, we're at the ordered pair 9, 0, so we get 0 for y. What is f of 0? What is f of 0? Looks like it is 13. Okay, so 13 is our answer. It's kind of a fun concept, but it can take a second to wrap your mind around, okay? Start inside. G of f of 1. F of 1, so when we plug 1 into our f function, we get 8 for y, right? G of 8 then is 15. So 15 is what you want. Think for a second, what do you get for this last one? All right, so if f of 14 is 9, if f of 14 is 9, then g of 9 is 0. So you should have gotten 0 there. Okay, that's all I got. Check your practice. Let me know what questions you have.